So we're now ready to run this column, and the first step is going to be to unstopper the ends of the column and let that silica, or the meniscus here, go to the top of the sand. I've got a pipette ready to add my compound. So as soon as that meniscus hits the sand, I'm going to want to add my column without letting, or add my compound without letting the column go dry. And then I'm also going to be flushing that on with some hexane, so I've got a pipette ready for hexane as well. And I'll just be grabbing the hexane out of that beaker. Move the TLC jars so they're out of my way. So those are ready for when we're ready to TLC our fractions. And you can see there's a little silica still at the top. So as this runs down, I'm going to just flush that to try to get all the residual silica off the side, along with any sand that may be sticking. If I wanted to, I could speed that up by pushing a little bit of air pressure. And I'll do that once we get the column running, to limit the amount of time it takes to run it. When you release the pressure, you want to do it gradually to make sure that air bubbles don't come up from the top and crack your column. This last little bits of persistent silica. The grade of silica gel we're using here is suitable for gravity column chromatography that we're doing right now. If we used a much finer pore size silica, that would be called flash chromatography, and that would actually require air pressure, or the column would run much too slowly. Little bits of silica. You'll see the sand got disturbed a little bit when I squirted that in. That's the purpose of the sand, to make sure that the layer of silica, we want it to be pretty flat at the top and the bottom so that it moves uniformly down. The goal is to add this in as thin a band as possible so that you don't get overlapping spots. So I'm going to start here when I run these fractions with 1A, then I'm going to go 1B, C, D, E, and then I'm going to go 2E in that, so I run a serpentine fraction. So this will be 3, 8, 13, 18, 23, and 28. Those are the ones I'll TLC initially when I'm looking for my product. So you'll see that the bottom of the meniscus is right at the top of the sand. And now I'm going to add my product, trying to get it as close to the top of the sand as possible, so I don't get it all over the walls of the column. And I'm going to let that go in under gravity before I add the next bit, so that I can try to get it in as thin a band as possible. The separation of the spots can't be any better than the distance from the top to the bottom of the volume of liquid that we're adding. This column, in truth, is nowhere near long enough for the quantity of compound we have, but this separation is also not a very difficult one, so we should still be able to get reasonably pure product. The biphenyl is very nonpolar, and I should actually have looked under UV light, because biphenyl is UV active but does not stain with phospholipid acid. So I'm going to go get a UV lamp once we're done with this column, so that when we look at the fractions, we'll be able to look for that UV active biphenyl spot. Phospholipid acid doesn't stain plain old hydrocarbons. It usually requires there to be an oxygen in the molecule somewhere for it to react with. Again, I'm going to let that go. You can see it's going on to the top of the column. What we're trying to get rid of here is any alkene from the acid workup. The mild acid workup may have caused some dehydration to occur ahead of time. We don't really want any alkenes in our time equals 0 for our dehydration. The biphenyl, which is the byproduct from the benzyne intermediate of the phenylmagnesium bromide reacting with bromobenzene, and then any of the aldol condensation product that might be present. We'd like to get rid of those. Those are all less polar than the alcohol that we're looking for, so we should be able to get rid of them in the early fractions before our compound comes off. At least that's the theory. So you see it's going on in a fairly thick band because there's a lot of it. The crude yield was quite high. If I had very little compound, I would actually flush this with hexane. But in this case, I think the benefit of getting this last little trace on there, given how much compound there is, would not outweigh the disadvantage of having a thicker band. So I'm going to use that in my TLC sample for my product by just squirting that TLC sample in there. And this will up the concentration of the TLC sample a little bit, which will allow me to actually put it on there in a sharper band and get a more coherent spot than I got that first time. So we'll put that back in there. And this will now be a fairly concentrated TLC sample. And that flask is ready to be washed. Oops. So that's still going down in. Once the bottom of the meniscus kind of hits the sand, I'll flush that on with a little hexane just to get the residue from around the edge. You can see it's dripping pretty slowly now because the compound is a little bit more viscous than the hexane. And we'll speed this up a lot once we have the column full. Now it looks like the bottom of the meniscus is at the sand. Just let that go in a little bit further. and just gently run a little hexane down the top. Try to convince that last little bit of compound to go into the silica before we fill up the column, because we don't want to fill up the column while the compound is still there in the sand and have it spread out. So a little bit of patience at these early going to make sure that we don't crack our column or expand our solvent or our compound band any more than it is already. One drop every 20 seconds maybe. It's actually good. It's going this slowly because it makes it easier for me to make sure the column doesn't go dry at the top. Okay, so that sand looks like it's dry just at the very top. Flush a little more hexane down. And you can see maybe that the solution is pretty clear, pretty colorless at the top, which probably means there's not much compound left. So one more cycle of this and then flushing with a little hexane should be enough to make sure that my column is, my compound is uniformly loaded at the top of the column. Now I'm going to do something to protect myself later, because one thing that you usually forget to do is to pre-weigh the flask. This is the flask that we're going to collect our fractions in. I'm going to sit that there to remind myself to get a tare mass of that flask. Also, probably make sure it's clean. Yeah, that looks like a clean flask. Alright, so it looks like the top of the sand's a little dry again. We'll just put just a little more hexane. You can see that that looks like it's pretty colorless now, which means that my compound's on there. And I will make this label. And this compound is going to be 52B. It'll be the purified product. And we'll tape that label on there. That way we'll have a mass of the flask, including the label. We'll weigh that. But first, to make sure the column doesn't go dry while I'm weighing it, put a little more hexane down. Nice colorless hexane layer, so that's good. So let's go weigh this flask so we have a nice mass. It looks like that's stable at 79.147 grams. 79.147 grams is the tare weight of the flask that we were going to be collecting our purified product in. And hopefully it'll be colorless. So we'll set that aside till we're ready. At this point I can fill this up completely. And start collecting fractions. Don't want to fill it right to the brim because when I apply the air pressure, I don't want it to splash. And then we'll just put a little pressure on that to get that flowing pretty well. So we want to make sure that the top of the column doesn't go dry, and also that we don't overflow our test tubes. And you see that I got a pretty good flow rate, but I'm going to need to refill my column. And I don't want to let it go too low, because when I refill the column I don't want to disturb the sand. That's especially important here at the beginning when the compound is still close to the top. And you see that you don't want to have to move it too much, especially when you're applying pressure, because you'd really like the liquid to all go in the test tubes and not around the side of the test tubes. So at 8 mils per fraction and 30 mils, I got about 240 milliliters capacity, but I've only made up a total of 200 milliliters of solvent, 50 of hexane, 50 of the 9:1, and then 50 of the 8515.